This is a passively stable drop glider. Its only purpose is to be carried high into the sky by my cargo drone and then be released mid-air. Usually I build RC planes with moving parts and flight controllers, but for this payload I wanted to design a completely 3D printable, passively stable system that flies itself and is as resilient as possible against headwind, tailwind and crosswind. What we want is a glider that can maintain an even glide slope once it reaches the required airspeed. This makes it so that right as the glider is dropped, its nose pitches up due to the increasing lift and pitch moment, causing it to level out and maintain its glide slope. Before launching it from the cargo plane, I'll be testing it with the custom pneumatic launcher. So first, I needed to come up with a design that satisfies the 3 stability criteria, which are pitch, yaw and roll. To maximize the lift to drag ratio, I tilted the wing up at the root and added a couple of degrees of washout at the wingtips. I adjusted the trim point to be at around 2 degrees near the peak of the lift to drag curve, which guarantees our glider will maintain a good lift to drag ratio, even if the nose momentarily dips due to a slight disturbance. To fulfill roll stability, I went with the high wing design, to which I added a couple of degrees of dihedral, which further improves its roll stability. To build this thing, I used a 3D printer to print the parts with, using really low infill and a 1-layer wall thickness. I decided to use normal grey PETG filament to print these with, because it's durable and I could print it faster than lightweight PLA. The weight isn't gonna be an issue, as the cargo UAV can carry it easily. These parts are surprisingly stiff, considering how little they weigh. After I had printed the parts for the glider, I glued them together with some hot glue. I figured that the hot glue would be a good choice, as it would be the point of failure in the event of a crash instead of the parts themselves breaking, but this turned out to be a bad choice, as you'll see later. I also marked the correct CG position on the underside of the wing. To get the correct CG, I had to put some weight in the front. For this, I used some coins, as I conveniently had them laying around. Then I put some hot glue on top to keep them in place. Once I had the finished glider, I had to figure out a way to launch it. I measured its weight to be 162 grams, which is a bit too heavy to be hand-launched, as it would have to be a really fast throw for it to reach a speed high enough for it to reach its glide slope. So I had to build a launcher for it. So I took inspiration from the V1 rocket's launcher, which worked pneumatically, and then designed my own launcher in CAD. When the barrel is filled with air, the glider accelerates. Conveniently, I had this aluminium pipe profile lying around, which was perfect for this. First, I had to make the piston for the launcher assembly, so I 3D printed it out of the same PETG filament, and it fit really well into the pipe, forming a good enough seal for our purposes. Then I cut some 20mm PVC pipe and used some 2-part epoxy to glue all of the parts of the launcher assembly to it. For the pneumatics, I used the solenoid activated air cannon, which I made in a previous video. To make it fit this mechanism, I needed to make this adapter for it, which allows me to directly screw it onto the solenoid valve to create a good seal. The glider attaches to the launcher using this hook, and after this was done, it was time to go test it, and hopefully it'll look something like this. It's quite windy here today, but I doubt it's gonna be an issue as this weighs so much. I'll first try to pressurize it to 2 bar, because I'm not sure how much acceleration this thing has, but I'm sure it's a lot, so I don't want to break it on the first try. 3, 2, 1. So I guess even that was too much pressure, as there was enough acceleration to completely rip off the tail and send the main wings right here. Luckily this thing didn't break, and I guess the hot glue wasn't the best choice here, as this is the point of failure. So I guess this was a good idea, but in practice it was never gonna work, because there's simply too much acceleration in this thing, which tore this thing apart and destabilizes it immediately. I guess I'll head home now and tweak this thing a little bit before testing it with the big plane. Because the hot glue failed in the cold weather, I decided to glue everything together with CA glue. This slightly reduces its mass. For the release mechanism, I replaced the hook with this thing, through which a pin goes and keeps it in place. To release it, I simply flip this red switch, which activates the servo motor and pulls the pin out. After I had everything ready, all that was left was to go and test it. So, now that I have everything set up, let's see how it flies. It's a bit windy out here, so I'll throw it into the wind and hopefully it'll take off like last time. 3, 2, 1. 2, 1. Oh, it flies well. I'll now put it in return to home mode and put it to circle around here. I put it to fly 50 meters high because that's the limit here. Okay, I'll soon drop it. 3, 2, 1. There it goes. It's really fast. Holy shit. And it crashed. So I guess I'll land this thing right now. It's coming in hot. It could have been a bit smoother. And it looks like it's in one piece. This tail thing fell right off, but I think it was glued on badly, so that's not an issue. And I'm surprised this actually worked. Let's go see how the glider's doing. I think it's there. Looks like this is a wing. The wing is still in one piece. Let's go see how the rest is. The tail fell off too. Where's the other one? So, I guess it worked. Kinda. I think it was a bit nose heavy. If you like this video, consider pressing thumbs up and subscribing if you haven't yet. And see you in the next one.